All right, this week we're going to be looking at graphing. The first three types of graphing we're going to look at are greatest common factor, factor by grouping, and factoring difference of squares. So the first type of factoring, greatest common factor, means you look for a number or variables that will go into both terms. So our first example is 8x minus 2. So we know that 2 goes into 8, or 2 is a factor of 8. 2 is also a factor of 2. So we pull that outside the parentheses. Factoring by greatest common factor is like the reverse distributive property. And then we divide to figure out what's left, or what goes inside the parentheses. 8 divided by 2 is 4, so we have 4x. 2 divided by 2 is 1, so 4x minus 1 is what's left inside the parentheses. A common error when one of the terms is the greatest common factor is students will just leave off the 1, so make sure that you check your answer by using distributive property. 2 times 4x gives us our 8x term. 2 times negative 1 gives us our negative 2 term. Without that negative 1 there, we wouldn't have a complete binomial after we multiply. Looking at our second example, 6x cubed minus 54x. We know that 6 goes into 6 and 54, and x goes into x cubed and x. So 6x is our greatest common factor. 6 divided by 6 is 1, and because we do have something left on that term after we pull the x out, we don't need to put that 1 there. So we have x cubed divided by x is x squared. With the variables, I also like to think about it as pulling one x out, and there are 2 x's left. 54 divided by 6 is 9, and the x gets factored out. X squared minus 9 is actually a difference of squares, so this one we could continue to factor, but we'll take a look at combination factoring later. Part C, looking at 10 and 5, our greatest common factor is 5. And we have an x cubed and an x squared, so we can pull an x squared out. 10 divided by 5 is 2. And when we pull x squared out, or when we pull 2 x's out from x cubed, we have 1 x left. And again, this time we pull the entire term out, so 5x squared divided by 5x squared is 1. At the bottom here we have 3x times the quantity x plus 4 minus the quantity x plus 4 times 4. So this looks a little bit different. It doesn't quite look like it's a greatest common factor, but if you notice, each term does have an x plus 4. So we're actually going to be factoring out the binomial x plus 4. And then when we factor that out, looking at the first term, we have a 3x left. Looking at the second term, we have a minus 4. Sorry if you hear that, that's my ringtone. I'm apparently getting a phone call right now. All right, second page, we've got factoring by grouping. This is when you see 4 terms, and it's grouping 2 terms that have a greatest common factor. So when I take a look at my first, my first quadnomial, there are 4 terms here, I notice y cubed minus 4y squared. They have a greatest common factor of y squared. So I'm just factoring the y squared out of the first 2 terms. Y cubed minus, or divided by y squared, or y cubed, when we pull 2 y's out, there's 1 y left. We pulled the y squared out of the second term, so we have a 4 left. With our second 2 terms, I notice that the greatest common factor is 2. I'm going to pull out a positive 2 because what I notice is the order of the signs on my terms goes positive, negative, positive, negative. What I'm going for here is that the binomial that's left after I factor is the same on both terms. So it'll be like that last greatest common factor that we just saw. So I'm going to pull out a positive 2 because I want a positive and a negative inside my binomial. So 2y divided by 2 is y, and negative 8 divided by 2 is negative 4. So I do end up with a y minus 4 on both terms. So that's now my new greatest common factor. So I factor out the y minus 4. What's left on my first term is y squared. And what's left on my second term is a positive 2. So our final answer is the quantity y minus 4 times the quantity y squared plus 2. On my next quadnomial, my first 2 terms I have a greatest common factor of 2x squared. 8 divided by 2 is 4. When I pull 2 x's out of x to the fifth, I have x cubed left. 6 divided by 2 is 3. I pulled the x squared out. Again, my terms are in the same sign order, positive, negative, positive, negative. So I'm going to factor out a positive 3 for my next two terms. 12 divided by 3 is 4. I have the x cubed left. And 9 divided by 3 is 3. So again, I have this 4x cubed minus 3 on both terms. So that's my new greatest common factor. I'm going to pull that out. And then what's left on my first term is 2x squared. And on my second term is a positive 3. And the last type of factoring is difference of squares. So the first thing that I want you to remember is what happens when we multiply two binomials that look exactly the same but have opposite signs. So a minus b times a plus b. Remember, when we're multiplying binomials, we use distributive properties. So we have a times a, which is a squared. A times b, which is positive ab. Negative b times a, which is negative ab. And negative b times b is negative b squared. So what happens when we simplify this is the positive ab and the negative ab cancel, leaving us with a squared minus b squared, or a difference of squares. So if we're factoring a difference of squares, we're going to factor it into two binomials that are the same except for their signs. So our first example here is x squared minus 81. So one way to organize your work is to take the square root of each term. So the square root of x squared is x, and the square root of 81 is 9. Once you know what each of those square roots are, you just put them in your binomials, x minus 9 times the quantity x plus 9. And that's in factored form. Our next example, we've got y squared minus 16, similar to our first one. Square root of y squared is y. Square root of 16 is 4. So we end up with y minus 4 times the quantity y plus 4. All right, sorry, I'm just trying to scroll down here so we can see some of these lower examples. So now we've got 9y squared minus 25. The square root of 9 is 3. The square root of y squared is y. And the square root of 25 is 5. So we end up with 3y minus 3y minus 5 times the quantity 3y plus 5. The next example, we have a power other than 2. As long as the power on your variable is even, it's a perfect square. And you just take the square root by cutting that power in half. So the square root of 16 is 4. The square root of x squared is x. The square root of 81 is 9. And the square root of y squared, y to the fourth, is y squared. So you just cut that power in half. And think about the reason that makes sense is that when you have y squared times itself, our exponent rule is you add the exponents. Alright, so the factored form of this one is 4x minus 9y squared times the quantity 4x plus 9y squared. And our last example looks a little different. It's not a difference of squares. We have a sum of perfect squares. One of the terms needs to be negative, and it doesn't matter if it's the first term or the second term. So in order to get this in the order that it makes sense for our difference of squares, I'm just going to take that square root of x squared and put it at the end, because that's our negative one. And the square root of 4 is positive, or our 4 is positive, so the square root of 4, 2, will go in our first set of parentheses. So we end up with 2 minus x times the quantity 2 plus x. So just think about the fact that in order to multiply to that negative x squared, one of the x's needs to be negative. And that is it. That'll be your assignment. We'll have a worksheet for our factoring.